This is CCEA A2 Pure Maths. We're looking at integration and doing some past paper questions. This one is from June 2015 and it's question 8. So a couple of different things, a bit of trig integration coming up here, and then this is going to be an integration by parts. So let's tackle part A first of all. So this is the integral of x squared ln x squared dx. U, because it's an ln one, we're going to let the u equal that. And I'm going to rearrange this. Hopefully we know ln x squared using our laws of logs is the same as 2 ln x. And then my dv by dx, I'm going to have then as x squared. Du by dx, if I differentiate ln x, I get 1 over x. So 2 times that is going to be 2 over x. And then my v is going to be add 1 to the power, divide by the new power, x cubed over 3. So I'm ready to do my question. So it's uv. So that's going to be x cubed over 3 times by ln x squared. And we'll just kind of change that back over. Hopefully that makes sense. Take away the integral of v du by dx. So there's going to be a 2/3 there. And then with an x cubed and an x down the bottom, so that changes into an x squared dx. The idea always of integration by parts is it turns a tricky integration into a more straightforward one, and this one's nice and straightforward now, so we're nearly there. So this is going to give us then x cubed over 3 ln x squared, and then take away add 1 to the power gives me 3, divide by the new power, so it'll be 2/9 x cubed, and remember then your plus c. Part B, just move it out of the way there, is the integral, if I do a line underneath here, between pi over 4 and 0 of cos squared x sine cubed x dx. There's a load of different ways to tackle this one here. It's definitely not going to be parts, because if we start to let this u equal u, this du x, it just ends up getting messier and messier. So we just need to do one of our things where we can change around some of these. So I'm going to rewrite it as integral between pi over 4 and 0 of cos squared x sine x sine squared x. It's quite easy to see what I've done there. It's the idea of actually coming up with it, which is a wee bit tougher, but we know that we kind of change these around all the time to 1 minus cos squares and stuff like that. So that's what I'm going to do with the next line. So it's going to be cos squared x upon sine x upon 1 minus cos squared x dx. Sorry, I'm going to put my limits in. And now integrate between pi over 4 and 0. This gives me this times a 1, so it's cos squared x sine x minus the cos squared x, so that gives me cos to the power 4 x sine x dx. And I can see that this is an awful lot easier now to integrate. I'm not sure if you can. If you differentiate something like, and this is just a wee bit off to the side, just a wee bit of learning for us, but say you have y equals cos cubed x, you might want to let u equal cos x and you work it out. But whenever you work it out, you get dy by dx is 3 cos squared x sine x. And it's the negative out there, and if you practice these for a bit you can kind of see, and I don't know if you can see, this looks really quite like this, only a kind of backwards version. So if we actually integrate this, we end up with some sort of then cos cubed x. If you have no idea what I'm talking about, you need to go back and look at some of the notes in for integrating something like this, but weirdly this is much more straightforward to integrate than cos squared x itself. So this is going to give us minus cos cubed x over 3. Again, look back at some of my videos if that doesn't make any sense. And here then plus cos to the power 5x over 5, and that's between pi over 4 and 0. So let's substitute our numbers in here and see what we get. Right, cos of pi over 4 is 1 over root 2. So if I have 1 over root 2 times 1 over root 2 times 1 over root 2, two of them will join together to give me a half. So it's a half times 1 over root 2. So a half divided by 3 is then going to be a sixth, and then over the root 2. It might be worth doing this one out separately, but you end up with minus 1 over 6 root 2. Then plus, so cos of pi over 4 again is 1 over root 2, but that to the power of 5, 1 over root 2 times 1 over root 2 of course gives us a half. So we have a half times 1 over root 2. I may have lost you there, I hope not. That means we have a quarter times 1 over root 2. Bringing the both down to the bottom, the quarter times the 5 there gives us a 20th. Times root 2. Thankfully the 0 is a wee bit more straightforward. You put 0 in, of course you don't get 0. Remember, cos of 0 was 1, so that's minus a third. Plus a fifth. And we can tidy that up a few different ways, but we end up with, I'm not going to do the third right now, but it gives you 16 minus 7 root 2 all over 120. You would join those together, common denominator, they both go into 60 root 2 and kind of tidy that up, and then rationalize the denominator. You end up then with that.